epsilon, we understood the concept of minimum points. Okay, we understood the concept of minimum points. So here in this case, in this example, we are trying to take one point, second point, S R P Q. These are the 4 points we are having with us. Okay, now, so there are some important points that are available. So any point, any point in the data space can be either a boundary point, it can be either a boundary point, or it can be boundary point, or it can be a core point. If any of the element, it is not either a boundary point or a core point, can be called as a noise point. Is called as a noise point. Okay, so this is very important. So you should understand, you should register three different words: boundary point, core point, noise point. Fine. Now, what is a boundary point? Okay, what is a boundary point? Now let us, before getting into the boundary point, let us understand what exactly is the core point. Okay, it is the point. Okay, we call this as a core point. No, it is the point in which we have number of points more than the minimum number, more than or equal to the minimum number of points. Okay, what is the minimum points we have assumed? So it is 3. So 1, 2, 3. So if you take that red circle with the epsilon distance from the point R, we have got 3 different points lying in this particular region. When you have 3 different points which is satisfying the condition, what is that condition? Minimum points condition, it is 3. So minimum points condition 3. So we are assuming that this, whenever we have this kind, this, so first of all, epsilon is the radius value, and it is having more than 3 points, that is equivalent or greater than minimum number of points. So these are two conditions. Epsilon is the distance followed, and number of points in this particular region is more than or equal to minimum points. So we call this particular point as core point. Whenever I said particular point is core point, so what you can assume that immediately, if you from that particular core point, if you draw the region with the space epsilon, you will find greater than or equal to minimum number of points. Okay, here we have assumed it is 3 as the minimum number of points. You find 3 points. So that is the reason we call this particular point as a core point. Is that clear? Now, you talk about, let us talk about S. What is happening here? Now, when you have S here, fine, we have drawn, this is the epsilon distance. Okay, this is the epsilon distance. Now, in this particular region, how many points we have? 1, 2, only 2 points, but it is not supporting minimum point. Okay, when we are, this is not satisfying minimum point, we call this as a boundary point. Is that clear now? A point can be either a core point or a boundary point. Why we call this as a boundary point? Now that is also very important. Why we call this as a boundary point? Because the distance between R and S is less than or equal to epsilon. Will you agree with me? Okay, the distance between R and S is less than or equal to epsilon. That is the reason S and R falling in the same circle. Now you see here, P, R, S, these 3 points are lying in the These 3 points are lying in the same region. Okay, so the distance between P and R, S and R is less than or equal to epsilon. This is also less than or equal to epsilon. This is very important. Okay, that is the reason. So in the region of S, R false. Why R false? Because how you have defined that region for S? We have identified epsilon as the radius and we have formed the region, circle region. So in this region R is also available. In this region R is also available. R is available because the distance between R and S is less than or equal to epsilon. Now if you take the same here, the region of point R. Now S and P are lying in the region of R because the distance between S and R is less than or equal to epsilon. So here also this is also less than or equal to epsilon. So this is the key important point. So the core point is such that you will be having more than or equal to minimum number of points. So this is the core point. Now if you take the case of this one, if you take the case of this one, what is this? You have taken a point. Okay, let us assume the circle, I have not drawn it clearly, that the distance, the region is epsilon region. How many points you have in this region? 0. What does it indicate? It is available far from point Q, far from P, far from R, far from S. Okay, so we call this as orphan element. What does mean by orphan? Noise. We'll simply identify that, keep it aside as a noise. So this is how the clustering algorithm, density based clustering algorithm will be revolving around the concept of epsilon and minimum number of points. Okay, now what about this Q? Is Q a core point or a boundary point? Is a core point or a boundary point? Now how many number of elements we have in Q? Let us assume Q, this is also epsilon. Now how many points we have? Q and P, 2 points. So definitely, so we have 2 points here, we have 3 points here, 1 2 3, and we have 3 points here. Okay, we have 3 points here, we have 3 points here. So now what is this? This is not boundary point because we have 3. This is also core point. And what about this Q? Q is called as a boundary point.
Last start time.
Okay. Clear? Is that clear? Have you got some idea? Have you got some idea about this? Fine. So preliminary section. Now we will switch to the next. Okay.